In this video, we want to discuss some of the algebra rules for finite sums. So we have the sum rule, and what is that? Well, we assume, we have the sum from k equals 1 to n of a sub k plus b sub k, where a sub k and b sub k are just sum formulas. It doesn't matter which. And if we add two formulas in here, or two expressions inside here, inside of a sum, we can then separate these. So this is the same as k equals 1 to n of a sub k plus the sum from k equals 1 to n of b sub k. All right. We have a similar rule for a difference rule. The sum from k equals 1 to n of a sub k minus b sub k is equal to the sum from k equals 1 to n of a sub k minus the sum from k equals 1 to n of b sub k. So again, we can just separate the addition or subtraction here and do the sum separately. What about a constant multiple? What happens here? So if c is a constant, then the sum from k equals 1 to n of c times a sub k is just c times the sum. Which makes sense, right? If we have c within each of these terms in here, then we can factor a c out of each term, and then it's just c times the sum of all of those terms when we factor the c out, after we factor the c out. So that's exactly what this says here. And a constant value rule. What if we have some constant c and we do the sum from k equals 1 to n of just the constant c? We don't have any, the formula is a constant, so we don't have any k's in here. Well, that just means c plus c plus c n times, which is c times n. And again, this is for any constant c. And just for completeness sake, let's write out a couple of useful formulas really fast using sigma notation. What is the sum of the first n integers? Well, it turns out this is just the formula n times n plus 1 over 2. In the previous video, we saw that the sum of the first 4 integers was 1 plus 2 plus 3 plus 4, which was 10. Well, what if we plug that into this formula? 4 times 5 is 20, divided by 2 is 10. So at least for this example, we see that that works. But we're going to go ahead and leave the proof. Proof's not complicated, but we're going to leave the proof out of this video. There's a few other formulas I'm going to go ahead and write down. What about the sum from k equals 1 to n of the first n squares? Well, this formula, it turns out, is n times n plus 1 times 2n plus 1 all over 6. In a previous video, we saw that the sum of the first 5 squares was 55. Well, let's go ahead and calculate that here. This would be 5 times 6 times 11 divided by 6. So the 6's would cancel. We just get 5 times 11, or 55. And the third formula I'm going to write down is the sum of the first n cubes. Turns out that formula is n times n plus 1, all divided by 2 squared. All right, and that is it for this video.